Telecommunications traffic during the 1990s has reached spectacular levels, and current estimates project its growth will continue at more than 100% per year. Tremendous increases in internet traffic, video conferencing, mass data transmission, transaction processing, and standard voice telephone service have collectively placed existing network systems at or near capacity. Competition in this environment is driving established carriers as well as new telecom players to dramatically increase bandwidth and improve network performance. At the same time, they must continue to grow their profits. Templex believes that addressing this market need requires an order of magnitude improvement in optically based telecommunication speeds, coupled with cost-effective implementation. Templex addresses these requirements via its breakthrough technology called Temporally Accessed Spectral Multiplexing, or TASM. Here's how it works. An optical data stream enters the passive all-optical TASM device, where it is encoded utilizing code division multiplexing, or CDM. This CDM optical data stream can then be decoded by a matching TASM device on the receiving end, thus restoring the original optical data stream. Multiple CDM-encoded optical data streams can be present on the same carrier. The TASM grating accepts light from one or more input directions and redirects the light into one or more output directions in a way that is dependent on the temporal waveform of the input light. The TASM link provides a complete, passive, all-optical asynchronous data link, which encodes multiple gigabit per second optical data streams into a single carrier terabit per second optical data stream, then passively removes the encoding, thereby restoring the original separate gigabit data streams, all without electronic intervention of the optical data streams. The TASM link offers enormous performance improvement when compared to traditional dense wave division multiplexing, or TDM systems. TASM benefits include dramatically increased telecom bandwidth and higher reliability through reduction in electronic component count, simple single carrier lasing requirements, as opposed to the multiple complex lasers required by DWDM, and most importantly, TASM provides a 1,000-fold increase in spectrum usage efficiency. TASM can be deployed as a terabit per second optical router in a header decoding configuration. After the optical data stream passes through an optical splitter, one copy is fed through a TASM device, where the TASM encoded header is directed to the appropriate discrete photodetector, thus triggering the routing logic. The optical data stream then passes out of the delay loop and into its newly assigned optical route, without electronic intervention in the optical data streams. A passive TASM device can be deployed to restore an optical signal through removal of all predictable dispersion degradation present on the carrier. Output from this TASM device is a fully restored, dispersion-free optical signal without electronic intervention in the optical data streams. Additional telecom applications include add-drop multiplexing, event detection, pattern recognition, serial to parallel and parallel to serial conversion, data encryption, and many others. The market for high-speed, high-capacity memory is growing at an unprecedented pace. This demand is driven by the increasing size of software applications and the datasets upon which they operate. Pressure in this market is further compounded by the fact that the central processors in today's computers spend 60% of their clock cycles waiting for data to be accessed from various memories. Templex addresses this large market need through introduction of a new entry in the data storage hierarchy, Optical Dynamic RAM, or ODRAM. Based on Templex's TASM technology, ODRAM offers hard drive memory capacity at near DRAM speed with compelling cost-performance ratios, all without moving parts. Here's how it works. During a write function, a data-encoded optical beam accompanied by a reference beam are directed through an acousto-optic beam deflector onto a discrete location for recording and storage in the frequency-selective memory crystal. TASM technology enables each discrete location to hold upwards of 100,000 bits. During a read function, an optical beam is directed through the beam deflector into a discrete location. As this beam passes through the memory crystal, it is encoded with the data previously written to that location. Passing out of the memory crystal, the now encoded optical beam carries a copy of the data. Templex TASM-based ODRAM combines low-cost frequency-selective materials, elimination of moving parts, and multiple bit storage per spatial location, providing a foundation for a new class of large-scale memory which can directly impact computing performance. Combining ODRAM with an equivalent capacity of hard drive storage offers a hybrid device which can dramatically increase system performance. On power-up, the contents of the disk drives are transferred to the ODRAM unit, where it is available to the system at 1,000 times faster random access speed. TASM ODRAM systems operate in serial mode, which makes them compatible with existing memory architectures. ODRAM can provide storage densities to 100 gigabits per square inch with microsecond access times. With 64-bit wide access, peak data transfer rates will be faster than that of silicon DRAM. The key to this access speed is TASM's ability to store as much as 100,000 bits per spatial location, as opposed to existing memory technologies which store 1 bit per location. Capacities to 100 gigabytes or more provide the industry's fastest large-scale storage system based on substrate modification class memory. Templex Technology Corporation was formed in 1995 to bring a new generation of optical technology called temporally accessed spectral multiplexing to commercial reality. We are currently seeking strategic partnerships that will expand our research and development efforts while prioritizing the growing list of identified applications where our products provide specific benefits within the telecommunications and data storage markets.